Hi everyone. In today's video, we'll be looking at a bit of mechanics. So we are given an engine block right here, which has a total mass of 650 kilograms, and it is suspended by a cable over a frictionless pulley. So we've got a learner here on the right. They are pulling a rope, okay, which is attached to the engine block in a horizontal direction towards the right, so that the cable forms an angle of 10 degrees with the vertical. It is then kept in this position. So now, in the first question, we are required to explain the concept of forces in equilibrium. So, what is an equilibrium? Okay, equilibrium, can think of it as balanced. Okay, so if you consider an object, we'll consider two cases, right? An object that is moving and an object that is at rest. So this object here is not moving, so its velocity is 0. This object is moving, let's say 2 meters per second, and it is constant, meaning that the velocity does not change over time. So let's consider the first case, right, where we've got a block which is motionless, so it's not moving, right? So equilibrium applies to these two cases where you've got a block which is at rest. Okay, so all of the forces acting on this block, we've got two forces. Okay, so the force of gravity acting downwards and normal force acting upwards. Okay, so these two forces, they are equal in magnitude but opposite in direction, so they simply cancel out. So this object here is motionless, right? So it is in equilibrium. Another case is where we've got an object that is moving in that direction. Okay, let's say we've got someone here that's applying a force in this direction here, causing the object to move to the right, and it is moving at a constant velocity. So what does it mean for an object to be moving at constant velocity? Okay, what this means is that the acceleration, okay, which is change in velocity over change in time. So since there is no change in velocity, so if our velocity is 2 meters, right? Initial final will be 2, right? Irrespective of the time, this acceleration here is 0 meters per second squared. So this object is moving but at a constant velocity. Okay, so there is no net force acting on it. So net force is equal to 0. Okay, so that's what it means. When it comes to forces in equilibrium, all the forces they balance out, canceling each other. So we consider two scenarios: a case where the object is not moving and a case where it is moving. So hopefully these two cases here will help to explain what it means for an object to be in equilibrium. So if you were to define this using words, okay, so when a body is in equilibrium, it will either be at rest, okay, or it is moving at constant velocity. Okay, so I'm just explaining the concepts to you so that you can understand it and then be able to phrase it in your own words. So let us move to the next question. So in question 2.2, we are required to draw a free body vector diagram showing all the forces acting on the engine block, indicating the magnitude of at least one angle. So we start off by putting a point, okay? And this pointer will serve as our engine block. So we've got several forces acting on this object. One in particular is this individual here pulling the engine block to the right, okay? So put a direction towards the right, okay? And then label it as F applied, okay? Next, we have the force of gravity, which will always be acting on any object with mass m. So that force will be acting downwards. So we'll label that as Fg. And lastly, the remaining force is the force of tension, right, which is in the cable. So here we've got this cable here pulling this object in that direction. Okay. So now that will be there. Okay. And we can just put a vertical line here just to indicate that this tension is being acted at an angle, okay, of 10 degrees to the vertical. So that is basically it. Okay. So this free body diagram illustrates all the forces that are acting on the object. Okay. And these forces are acting in different directions. And let's just put a label here. So we'll call this F of T, which is force of tension. Now, let us look at the next question. So in the next question, we want to find the magnitude of the tension in the cable. Okay. So in 2.3, we want to find the magnitude of the tension. So we need to refer back to our free body diagram that we had drawn. Okay. And then decide on how to go about doing it. So firstly, let us take this free body diagram and redraw it, right? But this time it won't be a free body diagram, but a closed vector loop, right? In other words, we're going to be having all our forces, right, interconnected. So I'm going to show that to you just now. By that, I mean just drawing a closed loop. So we know that the force of gravity is acting downwards, okay, which is Fg. And then we have the force of the individual applying on the engine block towards the right. So that is force applied. So what I'm simply doing here is connecting all these forces just to connect them, right? For the purpose of illustrating how you go about calculating this. And then lastly, we've got the force of tension acting in that direction, which is F of t. So you see here we've got a closed loop, right? It's not really any different to a free body. This case here is simply detailing all of the forces, okay, and then just forming a right angle triangle so that we can use trigonometry to find the tension. So now, and lastly, there's this vertical part here, right? So this is parallel to this line here. So recall that our angle is here, right? The angle that the cable makes with the vertical. So we can put that angle here as well. Okay, alternate angles are equal. And now we can proceed. So let me quickly just put some points here, right? So F tension will I'll just put that here, just so you know that this diagonal represents the tensional force. And then we have this F applied. I'll just put it here, okay, which will act as our force exerted by that individual. And then lastly, the force due to gravity. Okay, so we've got these three forces in our diagram. Now, let us go ahead and calculate. So let us check a few things first, right? We want to find f of t, right? When we're using trigonometry, your cosine, sine, tangent, you need one angle and one side, right? In this case here. So if we check here, right, relative to the angle that we had constructed here, okay, let us see here. We don't have force applied, right, because that wasn't given to us, but we do know that the force of gravity, we can always find it, right, by taking the mass multiplying by acceleration. Okay, so we've got that, so we can use that as a point. So that relative to this angle here will be adjacent. That part is adjacent, okay? And then the hypotenuse, which is our tensional force. So we can actually use cosine. So cosine of theta. So this theta here will be this 10-degree angle. So this then is equal to what? So cosine of theta is simply what? So if we look at our angle here, we take the adjacent side, which is f of g, and then we divide it by the hypotenuse, right, which is f of t. Keep note that f of t is unknown, okay? So we're going to rewrite this as f of t is equal to f of g divided by cosine of theta. So now we making a bit of progress, okay? So lastly, we just need to plug in our values, okay? So let us plug them in. So we'll have f of g, which is equal to 650 multiplied by 9.8. Okay, the 650 is the mass of the object and 9.8 is the acceleration due to gravity, which is a constant. We then divide this by cosine of 10 degrees. Okay, so now you can clearly see that all our values have been inputted. We just have to plug it into our calculator and get an answer. So once you plug it in, you should get an answer of 6,468.27 newtons. Okay, so now as you can see here, we found our tensional force utilizing trigonometry. And it made it a bit more easier to get this by restructuring the free body diagram we had, right? By just constructing it in a closed loop. Now, let us go to our next question. So in the next question, we now want to find, we now want to determine whether or not the cable will snap. So let's see what we're given, right? We are given that the cable can withstand a maximum tension of 7,000 newtons. What this means is that if the tension exceeds 7,000 newtons, then the cable will break. Okay. So now the engine block is now pulled further to the right so that the angle of the cable with the vertical is 32 degrees. Okay. Now we need to determine whether or not the cable will snap. So the only change here, right, if we refer to the diagram that we drew here, is the change to the angle. Okay, we're going to be changing that angle. So let's redraw that here. Okay, so instead of 10 degrees, we'll just put 32. So we'll have 32 degrees here. Okay, and we'll have FA the side, then we'll have f of g, and then f of t. So what we want to find here is a tensional force Ak. So we're going to be utilizing this same formula here. The only difference is that we're going to be changing the angle. Okay. So now f of t, we'll just rewrite it here, right? Is f of g divided by cosine of theta. F of g is the same. Okay. Our object hasn't been changed, but the angle has. Okay. So the angle is 32 degrees. So now what is the answer here? So once you plug this into your calculator, you should get an answer of 7,511.37 newtons. So now what we need to do is compare it with the 7,000 newtons that was given in the question. Okay. So the maximum limit is 7,000. Okay. And given that the angle has changed, okay, so now the required tensional force will be 7,511. But now we see that this 7,500 is more than this, right? 7,511.37 is greater than 7,000. So what can we conclude from this? Is that the cable will break, okay? So yes, it will break. Why? Because the required tensional force, right, needed for this whole system here to work, right? In other words, for the cable not to break, it will have to be below 7,000 newtons. And that is basically it. Okay. So in this session here, we had gone over this scenario here where we have an individual pulling a block. We had drawn free body diagrams identifying all of the forces acting on the block. And then we found the tensional force. Okay. And we also covered another case where the angle between the cable and the vertical has been altered. Okay. So what does this tell us? That if the angle increases, the required tensional force will increase. And that is basically it. Hopefully this video has helped you to understand how to go about tackling such questions. If you like the video, please like, subscribe, and share.